So, so for our topic for today, it's all about ordinary differential equation order 1, specifically variable separable equation. Consider the form, the function m comma x comma y dx plus n comma function of x comma y dy is equals to 0, where both m and n can be functions of x, y, or both x and y. We are given that this function, this function can be simplified and expressed as this, which is equivalent to 8 of x dx plus b of y dy is equals to 0. If this equation can be simplified and expressed as this, therefore, we conclude that this differential equation is a variable separable equation. So let's try example number 1. So we have quantity y plus 2 dx plus x minus 2 dy is equals to 0. First is I will transpose this one to the other side. So we're having x minus 2 quantity dy is equal to negative quantity y plus 2 quantity dx. So dividing both sides by x minus 2 and y plus 2, sorry, y plus 2, and to the other side also. So we will have x minus 2 multiplied by y plus 2. As you can see, on this side, x minus 2 will cancel out, while on this side, y plus 2 will cancel out. So we will have this dy all over y plus 2 is equal to negative dx all over x minus 2. Integrating both sides of the equation, so we will have first on the left side, I'll use u substitution. I let u is equal to y plus 2. Taking the derivative, so we will have du is equal to dy. On the other side, I will let v is equal to x minus 2. Taking the derivative, so we will have dv is equal to dx. As you can see, on our numerator, in this on the right term, we have a negative dx. So I'll multiply this one by negative 1. So we will have negative dv is equal to negative dx. Substituting our u substitution and our v substitution to the equation, so we will have integral of our dy is equivalent to du all over y plus 2. Our y plus 2 is equivalent to u. So is equal to integral of our right side, our negative dx is equivalent to negative dv all over our x minus 2, which is equivalent to v. So integrating both sides of the equation, we will have ln of u is equal to negative ln of b. As you can see, ln of c is also equivalent to c. So I can therefore, I can say that c is equivalent to ln of c. So I'll have plus ln of c. So using the rules of natural logarithm, I'll transpose this one to the other side. So we will have ln of u plus ln of b is equal to ln of c. Using the rules of logarithm, natural logarithm, take note that ln of a multiplied by b is also equivalent to ln of a plus ln of b. So I'll use this one in our uh, e- problem, in our solution. So we will have ln of u multiplied by b is equal to ln of c. Taking the exponential of both sides, so I'll have u times b is equal to c. We know that is equivalent to our u is equivalent to y plus 2, and our v is equivalent to x minus 2. So substituting this into our u and v, so we will have y plus 2 multiplied by our b, which is equivalent to x minus 2, is equals to c. Further simplifying our equation, our solution, so we will have y times x, which is equivalent to xy, y multiplied by negative 2, which is equivalent to negative 2y, plus 2 times x is equal to plus 2x. Then plus 2 multiplied by negative 2, we will have negative 4 is equals to c. As you can see, negative 4 is just a constant. So we can say that this will cancel out. So we will have x times y minus 2y plus 2x is equivalent to c. And that's the answer. Now let's move to our example number 2. So we are given that tangent of y dx plus quantity x plus 1 quantity dy is equals to 0. First, I'll transpose this one to the other side of the equation. So we will have x plus 1 quantity dy is equal to tangent of y dx. Dividing both sides. Dividing both sides by tangent of y multiplied by x plus 1. Also on the other side, so we will have x plus 1 times tangent of y. So as you can see, tangent of y will cancel out on this side. I should use another color. So tangent of y will cancel out. Then x plus 1 and x plus 1 will cancel out. So we will come up with this. We will have dy is equal to tangent of y is equal to dx all over x plus 1. We know that 1 over tangent y is equivalent to cotangent of y. Take note. But we also know that cotangent of y is also equivalent to cosine of y all over sine of y. Substituting this in our equation, so we will have dy multiplied by cosine of y all over sine of y is equal to dx all over x plus 1. Integrating both sides of the equation, so we will have integrating both sides. So on the left side of our equal equal sign, I will let u is equivalent to sine of y. Then taking the derivative of that, we will have cosine of y dy. And then on the other side, I'll use let b is equal to x plus 1. Taking the derivative, so we will have db is equal to dx. Substituting our u into our y and substituting our v into our x. So we will have integral of cosine of y dy is equivalent to du all over sine of y, which is equivalent to u. Equal to integral of our dx equivalent to v dv all over our x plus 1, which is equivalent to v. So integrating both sides of the equation, so we will have ln of u is equal to ln of b plus c. Sorry, I forgot the negative sign, which is this. So I'll put negative sign on this. It should be negative because I transpose it on the other side. So we will have negative ln of u is equal to negative ln of b plus c. So we know that ln of c is also equivalent to c. So by substituting ln of c into our c, so we will have negative ln of b plus ln of c. So that is also equivalent to ln of u. Using the rule, I'll transpose this one to the other side on our left side. So we will have ln of u plus ln of b is equal to ln of c. Using the rules of natural logarithm, I'll so we will have ln of u times b is equal to ln of c. Taking the exponential of both sides, so we will have u times b. So we will have u times b is equal to c. We know that substituting our u and our b, so we know that our u is equivalent to sine of y and our v is equivalent to x plus 1. Substituting this, so we will have quantity sine of y multiplied by x plus 1 is equals to C. That's the answer. Now moving on, we will move to our third problem, third example. So we are given that y e raised to 2x dx is equal to quantity e to the 2x plus 4 dy. So first is I'll divide both of the equation by e to the 2x plus 4 and then e to the 2x plus 4. As you can see, on our right side, e to the 2x plus 4 will cancel out. And then I'll divide both sides also by y. So it means that y will cancel out on the left side. So we will have this e raised to 2x dx all over e raised to 2x plus 4 is equal to dy over y. Then integrating both sides of the equation, so we will have first on our left side, I'll let u is equal to e raised to 2x plus 4. And then taking the derivative of that, we will have du is equal to e raised to 2x multiplied by the exponent of the exponential function, which is 2. And then the derivative for 4 is 0. So we will have du is equivalent to 2e raised to 2x dx. We know that we only have e raised to 2x dx on our numerator. So dividing both sides by this one by 2. So we will have 1 half du is equal to e raised to 2x dx. While on the other side, on our right side, I let v, sorry, is equal to y. Then taking the derivative of that, so we will have dv is equals to dy. So substituting our equation, we will have integral of our e raised to 2x dx, which is equivalent to 1 half du. I'll move 1 half on our integral, so we will have 1 half du all over our e raised to 2x plus 4, which is equivalent to u. So is equal to integral of dy over y, which is equivalent to the integral of dv over b. So multiplying both side by 2, so I'll have 2 integral of du over u is equal to, sorry, this should be, this should be integral of du over u is equal to 2 integral of dv over b. Integrating both sides, so we will have ln of u is equal to 2 ln of b plus c. Then, using the rules of natural logarithm, so we will have ln of b squared plus c is equivalent to ln of u. Substituting the values of u and our b, so our u is equivalent to e raised to 2x plus 4. So we will have ln of e raised to 2x plus 4 is equal to ln of b. Our b is equivalent to y. So we will have y squared plus, we know that ln of c is equivalent to c. So I can say that it is equivalent to this. Then I'll use the rules on natural logarithm. So I'll have ln of, first I'll transpose this one to the left side. So 2x plus 4 minus ln of y squared is equal to ln of c. And then using this, so using uh, natural logarithm rules, so we will have ln of e raised to 2x plus 4 all over y squared quantity is equals to ln of c. Taking the exponential of both sides, so we will have I'll just change my pen. So we will have e raised to 2x plus 4 all over y squared is equal to c. Then transposing y squared on multiplying, cross multiplying, so we will have c y squared is equal to e raised to 2x plus 4.